Here we have section 7.5, parts of similar triangles. So main idea is recognize and use proportional relationships corresponding to perimeters of similar triangles, and then recognize and use proportional relationships of corresponding angle bisectors, altitudes, medians of similar triangles. So I got theorem 7.7 here, which just says that if two triangles are similar, the perimeters are proportional to the measures of the corresponding sides, which means you can set up a proportion using a pair of sides and the perimeter themselves. All right, so example 1, GHK similar to TVW, then gives you the measures which are already labeled. Find the perimeter of GHK, so the smaller one. So I'm going to set up a proportion. So for 5 over 12, bottom over bottom, is equal to, I don't know the perimeter of the small one, but I do know the perimeter of the large one. It's 37 plus 35, which is 72, plus 12, which is 84. So if I do cross products, 12x is equal to 420, divide by 12, gives you 35. So the perimeter of the small triangle is 35. Now if you really wanted to, you could solve for each individual side and then add them up. So you could do 5 over 12 is x over 35 to get this side, and then do 5 over 12 is x over 37 to get that side, and then add all three sides together. But this way you just have to set up one single proportion. All right, theorems 7, 8, 9, and 10 here just deal with the proportionality for altitudes, angle bisectors, and medians. So they are also proportional if the triangles are similar. So example 2 here, the two triangles are similar. BG is a median, which means that that is congruent to that. And EH is a median, which means that is congruent to that. Given these values, BC is 30, BG is 15, and EF is 15. Find EH is x. So it doesn't matter that these guys aren't sides, you can still set up a proportion. So BG over EH, median over median, is equal to side over side. So cross products would give you 30x is 225. So x is 7.5. Now on this one there is actually a faster way to do it, but it requires some confidence in your number sense. So if you notice here, 15 is half of 30. So down here, 7.5 is half of 15. So if you can see the pattern between the numbers, that has to hold true because they are similar. Now in some cases it'll be easy like that. It'll be half or doubles or divide by 4s or things like that, but 9 halves are kind of tricky to see, but the proportion always will work. Okay, example 3 here, the drawing below demonstrates, so you've got a camera, so you have the back of the camera where the film is, and then the distance from the lens to the film itself, and over here you've got another triangle, so some height of the sculpture, and then the distance from the lens to the sculpture. So you actually have two triangles here, you know the base and the altitude of this one. Here, you are trying to solve the base, and you know the altitude. So once again, you can set up a proportion. So the base of one triangle over the base of the other triangle is equal to the height over the height. So 42x is equal to whatever 35 times 6.16 is, 215.6, divided by 42, 5.13 repeating. Which if you want fraction, that is 5 2/15. And this will be in meters because this triangle has units of meters. The last one here is you have the angle bisector theorem, which is another thing that a bisector can do. So if you have a line, which CD is the bisector, AD over DB is equal to AC over BC. Because what happens is these two triangles are split in half, and then they are similar to each other, which means you can set up proportions. So just remember it's side paired with side, base paired with base, and you'll be fine. And that's the end of this section.